Hello, so today we're going to talk about more about the exception handling. If you could subscribe to my channel, I'd appreciate it so I know to make more videos and give it a thumbs up if you like it. And today we're just going to go through the do, try again. So with a catch block, we have here our catch block right here, and that's also called a catch clause or an exception handler. And within that, you can change this then to an E for the placeholder, but I'll talk to you about that in a second. We have here the System.err, which is the error standard error stream, part of the java.lang program, which I'll talk to you in a minute about as well. And then we have our try block, which is different to our try statement because our try statement includes our try and catch, but our try block, once the local variables within that, once all of these are finished, then they go away or they go out of scope. That's really important because this is also similar to how methods work with our method call stack, right? So our method call stack, when we have our method up here, and let's say we have it throws the exception and it doesn't get to the return, but the process of control then goes down to our catch, and the local variables within this, so our int num and denum are gone, so they're now out of scope. Important to remember this. And then within Java, then it's also important to remember that it's multi-threaded. So we'll talk in more detail about multi-threading a little bit later, but with multi-threading, the model of program execution is concurrent. So we have multiple things happening at once. But if a program has one thread that has an on-call exception, it will cause the program to terminate. So what we said with the fault tolerant systems and things like that, we need to make sure that it doesn't fall, or that it falls gently so we can catch them. Catch me if you fall. So this is the method can throw exceptions that have an is-a relationship, and we spoke a bit about is-a and has-a relationship when we came to I keep calling it collections, but it's not. When it comes to inheritance, and the JVM then throws an arithmetic exception object, and then it implicitly calls the toString for the input mismatch, because we know it's toString because within our source, we have our source override implement methods, and we have our multiple things that are inherited from it. Okay, so I'm going to see you in a second, and I'm going to write out some more things, and then you can see what we're talking about. So please subscribe. Yeah, that's really important because I don't know whether you like the videos or not. So, and I'll see you in a sec. Hello and welcome back. So I'm going to take a little run through of this exception handling and explain some things to you while we go through it. So there are every class within Java inherits from class object, as we know from inheritance when we covered that. So we know with inheritance there are certain things when you inherit. So we actually also, by indirect inheritance, also inherit from throwable. So this is also part of where we can use the throws here, and then set our arithmetic exception here. So with this, we also have a couple of things to remember. So we spoke about the call stack, and that it has, when you have a method, there's a task, and like an employer has an employee, the employee can go off and ask multiple other employees to do a task and then come back. So you can call multiple methods within a method. You can't nest methods, but within that, then every time that it returns a control, you have a return address, and then that piece of memory that you use for those variables finish and are gone, so they're out of scope. So they go away is the term that I used previously, but they're actually out of scope now. They're gone. They're sent to garbage collection. So they're not available anymore. So once the quotient method returns if there's an exception thrown, then that is gone already. The same with the try block. So there's a distinction between the try block and the try statement. So the try block is just this block of code, and once this is complete, like any normal block of code, once it's finished, then it is finished. Then those variables within that are out of scope. And then it moves on to the next one. So with a catch then, a lot of programmers, what they do is just put in like a placeholder here. If I refactor it and rename it and just call it E, that happens a lot. And here we also need to refactor it if it works, and just call this E, and that's the exception within this catch block. So each of this try with these catch blocks is called as try statement. So they go together. Within this, then we can also have multiple within here. So using the operator here, you can add multiple different catches within it. There's also another point to note, and that's when we have the System.out printf here, because we have an input mismatch exception. This basically, it implicitly calls the toString method. So even though in the quotient it does not return, if this does not return a value up here in this method, if it doesn't return a value because there's an exception thrown, then these are gone away. So the local variables, they go out of scope. And that's the official way to describe it. So that would be your call stack. So like I said previously, you have a stack of plates, then you have you push on and then you pop off, and once it's popped off, it's gone, it's sent to the garbage collector. So it's listed within the Java virtual machine for garbage collection. And then there are certain errors that are also within Java. So every class has certain certain classes that they inherit from, so indirectly or directly. So every class inherits from object, as we know, indirectly then from throwable, but also from other classes, and one is error. So if there's, let's say, if you run out of memory, if there's an error with your Java virtual machine, then it will throw an error because it's taking from that object, from the error object in the java.lang package. So when you look up any of the Java API's packages, you can look up the java.lang and it will show you that there are classes that we can inherit from. There's exceptions and errors that inherit from throwable, and then there's runtime exceptions and other exceptions. So runtime exceptions are basically unchecked exceptions, and that means that we've already covered them as well. So this array index out of bounds. So when you have, for instance, I'll put it before here so we can demonstrate. When we have a for loop and we have our int count is equal to 0, and then we have count is going to be less than array.length when we define it, when we define array, and then count plus plus. So here, if our array, if we said array less than or equal to, that would be your array index out of bounds. Usually that's the issue because it's zero-based counting, as we discussed before, and it's one of the most common errors. I've made it myself, it's fine. Everyone makes these same errors in different contexts as well. So the JVM though throws an arithmetic exception. So the Java virtual machine throws an arithmetic exception. which is this one. It's part of the java.lang package as well. And then with each of these, it's good to know the certain things within the call stack. So it all comes back to the same data structures video that I posted, and that is you have a stack of plates. When you send them off to do something, when the method goes, the employee goes to the other employees and comes back with a return address, then those local variables within that are gone. They're out of scope. They go away. They're finished. And it's the same with this quotient method here. So we have our return num and denum, and even if you do not have a return, because it automatically then the flow of control goes down to the catch. Here we have our System.err, which is actually part of, I'll show you when we open it. So it's part of our print stream. So it's our System.class, which is the error with our print stream. And this is what it's called, error. So the standard error output stream, and it's similar to the way we write our System.out.printf. So that's it in a short version. We have also other exceptions that we're going to go through, including a finally keyword. So like we said before, there are certain keywords. So if I say, if I have my source, and then if I go to override and implement, we have finalize, not to be confused with finally. And that's a different thing altogether. But we also have the throwable, which is part of another class that's inherited, and then we have exception, and those exceptions can be runtime exception or an input-output exception. And then within that, then there's other exceptions. So index out of bounds, array index out of bounds, input mismatch exception, null pointer exception. So if we have the default, which is really important, the default for string. In the previous video, I was talking about the default for int and the default for Boolean. Default for Boolean is false. Default for string is null, and for reference types. So you get a null pointer exception if there's no assignment to it. Class cast exception and arithmetic exception. So we've almost covered a majority of them there. Then there's the regular error, which I just spoke about, which is the Java virtual machine error. So if there's run out of space, or if there's something wrong with it, then that's a problem. Then you have the AVT error and the thread death and the virtual machine error, which I just spoke about. There's also one other thing that we need to discuss, and that's threads. So with here we have a program. And then for the program things that are happening concurrently, concurrent processes, there are threads. And then there's more official ways to talk about it later on. But Java, it uses a multi-threaded model of program execution. So each thread then is happening concurrently. So if a program has one thread, an on-call exception will cause the problem to terminate. And like I said, with the catch, then we have different ways. So we have type 1, type 2, type 3, and then we can have an E here. So we can pull this up here and put this here, and then maybe have another one. This is generally speaking the way we'd write it. And also to remember, the placeholder E is usually in place in a lot of places, from what I've seen, including in different programs. So I used to do Java development for a healthcare company a long time ago, and it was part of systems called Pegasystems, and they were also written in a similar way as well. Yeah, so that's it for this. We'll talk about the finally in a second, but for each of the try, there has to be a catch. Within this, then we have our do while. So all of it's within a block. The try has to be in this block, then has to come with a matcher catch, but also the try, once it's terminated, then the things go away, similar to methods on what we've spoken about. And then this only happens when continue loop is true. So yeah, you can set it on and off here basically from it. So it's always it's set to true on the entry point of the program, so true, and then it says okay, it's true, do it. So it's going to say try this first, try doing these. That's fair enough, straightforward. And then the main thing that it does is try to get the result from the quotient, so the numerator and denominator, and that's where your throw comes in. So throws arithmetic exception, and once it throws the arithmetic exception, it catches it and has our system.err printf here, and then our actual error. So if we run it one more time to have a look, so if we have our 100 again and 7, we're going to say arithmetic exception, so it's going to be 0. Then it shows you 0 is an invalid denominator, and where is that in the process of control? It's right here. So if I change this to Ali, then it will also show 100, 0, Ali, right there. So it's just dependent on what you write within it as well. So these just make sense. With the E here, it's usually the kind of placeholder that's written for the usually, but it depends on the style and the company and where you're going as well. Okay, in the next we're going to do finally. So thanks for watching.